Hello, this is a video on the solar system. It's the fourth in a series which I have prepared, and this is on magnetic fields. The first three solar system videos that I did were on orbits, moons, and tidal forces, and those all went together to a certain extent. It would be best if someone was watching them, if you did it in that order. You don't have to, but that would probably be best. But this one on magnetic fields is really independent of the others. In this video and on the others, it's not like I'm going to prove that God created the solar system, but I do think we can provide understanding of aspects of the solar system that point to a created origin rather than a naturalistic origin. In this particular video, unlike the other ones showed some difficulties with a naturalistic origin and also a few difficulties with assuming a very old solar system. But this one is actually going to provide some evidence for a very young solar system. Magnetic fields. Okay, there are a number of bodies in the solar system that have an internally generated magnetic field. The sun has the most powerful one of all. Then the planets Mercury, Earth, Jupiter, Saturn, Uranus, and Neptune all have internally generated magnetic fields, and two of the moons of Jupiter, Ganymede and Europa, do as well. There may be a few other moons in the solar system that do. Probably won't be too many because we know about most of the big ones, but we haven't gotten close enough to measure all of them. There is no internally generated magnetic field on Venus, Mars, or Earth's moon. However, the moon and Mars used to have a magnetic field. We have some evidence from the rocks on the moon and Mars that there's remnant magnetism, which would have been formed by an earlier magnetic field. Whether Venus ever had one or not, we do not know. It'll be very difficult to ever get at a rock from Venus given the nature of the atmosphere and the heat there. We're most familiar with the Earth's magnetic field. It has a diagram here, and if you imagine a bar magnet coming north and south, and the magnetic field lines going out around from the bar magnet, that's a sort of a picture of the magnetic field. And if you think it got upside down because the S is pointing to the north, that is actually not correct. It is the south pole really does point to the north on Earth's magnetic field. That means that if you've got a compass, the compass north needle points to a south part of a magnet. And so really the Earth's magnetic field is oriented like that. It has some good things that it does for us. It provides protection from solar radiation. It's used for navigation. And the question is, how was it formed? Well, to try to come up with a way that you can have a magnetic field that exists for an astronomically long time period, the going theory right now is called the dynamo theory. And this is standard for representing the magnetic field on Earth and also for other planetary bodies and other celestial bodies. The idea is that because the Earth rotates, the rotation and convection of the liquid iron in Earth's outer core generates a magnetic field. Now, it's complicated and there's some issues. Trying to model this numerically has not been too successful. I'm not sure I understand why it's not been too successful. Maybe just because it's too complex. You know, you can model anything with a computer. It doesn't have to be real. There is complexity of the fluid motion involved, and it's hard to explain things like reversals in the past. We are sure that Earth's magnetic field has flipped in the past so that north became south and south became north, and other changes have happened over time. It's a little bit hard to get all that coming out of the dynamo theory. An alternate theory was proposed by Thomas Barnes in 1971. He was a physicist, also an astronomist at the University of Texas at Austin. I almost wonder if they would employ a guy like that today since he was a young Earth creationist. And he proposed a young Earth creation based idea in 1971. He wrote a book on it in 73, Origin and Destiny of Earth's Magnetic Field. And the idea was that God created Earth's magnetic field, and now it's in a state of free decay with a half life. The decay is due to electrical resistance in the core of the planet, and the rate at which a magnetic field decays is dependent on the characteristics of the planet's core. Now, exponential free decay with a half-life is very common in nature. Lots of things behave that way. Things like um, radioactive elements and whatnot. In 1971, he published this paper, and you can see way too many numbers here, but I'll highlight what you might ought to focus on there. If you look at the table, in 1835, this is a measurement that's highlighted here, a measurement of the strength of Earth's magnetic field, and it's called the dipole moment. That's one of the ways, probably the best ways, to measure the strength of the Earth's magnetic field. And in 1835, when they very first made some kind of measurement, 8.558 times 10 to the 22nd was the figure there. And if you go down the table, you'll see that it gets less and less. And he had the idea that what this meant was the Earth's magnetic field was stronger in the past. If you went back before 1835, it would be stronger than what it is there. And continuing on into the future, it'll continue to get weaker. He calculated a half-life of about 1,400 years. I think that number might need to be revisited. I ran a calculation with some newer numbers and came up with a half-life of actually a little bit less, but I'll let better scientists tackle that, I think. But with a half-life of 1,400 years, that implies that if you went back 7,000 years ago, the Earth's magnetic field was 32 times more powerful than it is today. That would be really powerful. And it might change a few things as far as it would definitely change some things as far as how things would be on Earth. But it's certainly livable. It wouldn't be impossible. But if you continued that exponential growth going back into the past, it would be impossible to go back more than about 15,000 years. That would make Earth's magnetic field impossibly powerful. So this is a young Earth creation argument. You can't go back more than some thousands of years and have a magnetic field like this. The theory also has an inherent prediction. One of the difficult things about studying science as it relates to the past and a subject like the age of the universe or the age of the solar system or the creation and evolution is that nobody's side can very easily make a prediction. In science, you like to develop a theory, use the theory to make a prediction, and then test it. It's hard to do that with origins related science. But this is a case where you actually can, because this theory has an inherent prediction that the decay will continue indefinitely into the future. That's because there is no dynamo, so there's nothing to add strength to the field. It will just continue to decay. Now, this picture is a fellow named Russell Humphreys. Humphreys developed this idea further and expanded on it. He updated it through 2011 was his most recent paper that I have. And he's probably getting up there a little bit in age now. So going forward into the future, it might be good for somebody else to carry the flag, so to speak. But he modified the theory to address reversals in the Earth's magnetic field. There were times in the past where we know, based on remnant magnetism in rocks, that the Earth's magnetic field flipped. North became south, south became north, and it happened multiple times. He also applied the theory to other bodies in the solar system, and very significantly, he also made predictions about it. This was one of the more influential articles that was written in the Creation Research Society Quarterly. The date on it is 1984 by Mr. Humphreys, and in it, he proposed a theory of the creation of planetary and magnetic fields. And he really just took Barnes's idea and proposed that God had created a magnetic field for every planet out there. And the magnetic field is roughly related to the mass of the planet. And on this table, the key thing to look at here is what I've highlighted there, and that's the present strength of the magnetic field of each of the planets and the moon. Now, you may notice that there's nothing there for Uranus and Neptune because in 1984, he knew nothing about it. And however, Humphreys made a prediction. He predicted that when we flew past Uranus and got some reading for it, it would have a dipole moment on the order of 10 to the 24th. That will be quite a bit stronger than Earth. But how could we ever know? Well, calling Voyager 2, here's our Voyager 2 spacecraft that in 1986, it in fact did fly past Uranus and found out that it did have a magnetic field of about that intensity. So Humphreys was correct in that prediction. He also predicted that there would be a magnetic field on Neptune comparable to Uranus. Voyager 2 eventually flew past Neptune, and that prediction turned out to be correct as well. He also made this prediction. He said that older igneous rocks from Mercury or Mars should have natural remnant magnetism, as the moon's rocks did. That's because Mars originally had a magnetic field, but its decay was so rapid that you don't have one anymore. But he said because it did in the past, if you look at Martian rocks, you could probably find remnant magnetism, indicating that there was a magnetic field in the past. In 1984, we did not know that that was true, but this has turned out to be correct as well. Mars did once have a magnetic field, and it's widely accepted today that that is true. I'm not quite sure what he meant about Mercury with remnant magnetism because Mercury actually has a current field, so of course it would have a past field. Now, also, when you look at the planets, the fact that some of them have a magnetic field is a little bit of a problem. Mercury is a good example. Mercury rotates very slowly. It takes 56 days to make one rotation. If you were on the equator of Mercury, where it would be rotating the fastest, you were standing on the equator, it's still only going 7 miles per hour. If you were down inside the planet, closer to the core or slightly away from the equator, something like that, it would be even less than that. Maybe that's too slow to generate a dynamo. At the time of Humphrey's paper, there was also doubt about a field around the gas giants because they weren't sure that an ice giant would have a suitable uh, liquid in there to generate a dynamo. In 2011, he did write one more paper on this. He's written several papers. I'm just mentioning two of them, but 2011 was the most recent one. And in this, he updated a table and he goes from 1900 to 2010. And he shows that if you look down that thing that I highlighted, we had pretty good numbers from those from beginning in 1900. And you can see that it steadily decreases. Every 5 years, you get a lower number, lower and lower and lower, until finally you're down at 7.74. Now, notice that this is, I don't know, it's like about 40 years after Barnes's paper. So Barnes had made the implicit prediction that the strength of the magnetic field would continue to decay, and that has proved to be correct. Nobody apparently has written a new paper on it since then. So I calculated some updated figures based on the International Geomagnetic Data Field. In 2015, it was down to 7.72, and in 2020, it was down to 7.707. So the decay continues. So this theory has some predictions. That magnetic field decay will continue on Earth. Also, the decay might be measured on other bodies. Mercury is a good candidate because, based on the present strength of the field, it likely is decaying pretty rapidly. And so, over time, you might can see the same thing happening on Mercury. Also, the decay will be shown to be exponential in nature. Now, real quick, going back, that column there, if you're to graph that and have a 1,400-year half-life, but you've only got 110 years to graph, that's gonna the graph of an exponential decay and the graph of a straight line is, I mean, they're going to look practically the same. But eventually, you'll get enough numbers to where we should be able to show that this is exponential in nature. All bodies had a magnetic field, and so it may be possible if we ever got a good look at rocks from Venus or the very large moon Titan or something like that, you should be able to find remnant magnetism on those too. So this is a good line of evidence for a young solar system creation. I hope you've enjoyed it. This is my last of the 4 videos on the solar system. I've enjoyed giving them to you, and we will talk to you later.